Right, okay, so my first experiment, I wanted to see how strong paper was and could it take a fair amount of weight. So first of all, what I needed to do was take a shape that we know is strong, so a cylinder shape. But then I wanted to think about natural structures, such as sort of like the honeycomb effects in beehives, etc., and combine the two. So first thing I needed to do was produce some tubes. So what I've done, I pre-cut some paper to 100mm. I then took the paper, used a pen, okay, so a board marker, okay, wrap the paper around the board marker to create, if you like, okay, a number of tubes. Each tube, as I said, measure 100mm in height, diameter 18mm. So I had to do this a number of times, in fact it took me several hours. So what we ended up doing was producing a tube. So I had to produce a number of these. So what I managed to do, I spent my evening while watching television, of course, and produced 153 tubes, which I've got to put next to each other. And what I've done is put some tape, mask tape on the outside to stop the tubes falling apart, because they won't stand up on their own. I've weighed the tubes, so what we've got some paper here that weighs 0.28 kilograms, so it's not very heavy at all. We're talking about 51 A4 sheets of paper. So what can I use for some weights? So first of all, I created if you like, a box to give me two shelves, if you like, so I can sit those on, and I needed then something to add weight. So looked around my shed, and what I come up with, transformers. Now this transformer here, okay, weighs 15.6 kilograms. So the weight of 15.6 kilograms, will the paper support 15.6 kilograms? So the only way of finding out is to actually try it. Now I haven't actually tried this yet, so if it doesn't work, the experiment is going to be a failure before I even start. So, okay, the tubes, as you can see, can quite easily support that much weight. Now I created this shelf, device, if you like, just so that I give myself another surface to load up again. So, what else do we need? Another transformer. Now this transformer weighs 13.4 kilograms, so if we put this on top, and we can see if the paper's full. As we can see, quite easily the weight's been supported. So what we've got here altogether is about 30.7 kilograms. As we can see, that is relatively strong, relatively supportive. But now I want to go heavy. So let's ditch the transformers. And take a piece of timber. What I'm going to do is, I'm now going to set this on the floor, put the timber on top to make that supportive. So what I now think I need is something that's going to be a bit heavier. So I've looked around my shed and I saw my reflection in the window. I weigh about 92 kilograms. So we're looking at, I'm about 3 times heavier, okay, than the two transformers together. So let's see if this will take my weight. Okay, you can't see me, but let's see. So, as you can see, quite easy, that takes my weight, and even if I bend my knees and bounce up and down, okay, that's quite stable. What I'll do now, as you can see, I'm going to pick up the transformers as well. So I'm now going to increase another 30 odd kilograms there, so we're now going to be taking us about 120 kilograms. So that's quite a lot of weight to be supported by, if you like, a few sheets of paper. Again, structurally sound. Okay, so as you can see, it gave way, but that was through shear. That gave way at that point. Okay, through shear stress, because as I stepped off, I didn't step off evenly. So as I stepped off, pressure went sideways. So now, if we look at our paperwork, the shear pressure has actually caused it to slightly collapse. And if we look at the configuration, we can see that the actual circles have now squashed over. If we had means of fixing the outside better to take away the possibility of the tubes falling over sideways, what would have happened? Okay, I'm sure that would have stayed more intact. So what we can evaluate from this is, the tubes upright are actually quite okay. Will take compressive strength as long as we've got no shear force hitting this. So, is paper structurally sound? It is, as long as we can secure the outside edges, and again, it's lightweight.